All right, so our plan for today is we're going to add on your third conic, which is called an ellipse. Oh, you're missing a stack of papers, aren't you? Yes, because you were. Okay, so today we're going to do the ellipses, and then we'll do your note sheet, and we're going to do some of those select problems on that practice worksheet. If you want to go back and finish any of those, I posted those solutions for you in case you want them. Tomorrow, what we're going to do is your hyperbola and some practice with that. And homework for this week, you've got 2 textbook assignments and a conics review sheet. The conics review sheet is in the stapled packet. It's like, I think it's the last document, but I'll make sure that you're aware of it before you leave tomorrow. Okay, so in front of you today, again, you need your conics formula sheet, your ellipse 10.3 blank note sheet, and the 10.3 practice sheet too. All right, so we're going to do the last 2 conics this week. After this unit, when you return next Wednesday, we're going to review all 4 of your conics, and then we move into your last and final unit of the year, which is series and sequences. And then final exam review as well. All right, so I am going to start right at the formula sheet, actually. So I want you to grab your formula sheet, and I want to discuss a couple items on here. Now, obviously, I'm aware that many of you are now eligible for your vaccine, which is great. So if you happen to get an appointment and you miss class, it's okay. I'm going to just record everything from here till the end of the year, okay? So just look right on Google Classroom, and usually I record either period 1 or period 2, and then I'll kind of post it once it uploads. So if you have to miss, it's okay. You won't fall behind as long as you kind of rewatch your lecture afterwards. So formula sheet here first. Up at the top here, this is what we call general form, just like you guys worked with before break. And what you've seen so far up to this point is a circle and a parabola. What distinguishes a circle once these get all mixed up is that your value of A is always equal to your value of C. Like this could be a 2, and then this would have to be a 2 as well. The next conic that we did was a parabola, and your parabola is either going to have an x squared or y squared, not both. So A or C will be 0 and not present whatsoever. So what you might want to write for yourself is that, again, you're going to have x squared or y squared, not both. So just those 2. And then the third conic that we're going to discuss today is known as an ellipse. So an ellipse is going to follow one of those 2 equations. So your A value is what you're always going to be looking for, and that's the biggest value, and that determines what's called your major axis. So this right here, when your A squared is over your x term, this would have what we call a horizontal major axis. So this one is a horizontal major axis. And then my second equation here that has the A squared underneath the y, this has a vertical major axis. So this one is a vertical major. The vertical major. And I'm going to draw little pictures for you just so you kind of see what these look like. And I'm going to exaggerate these just for the purpose of your notes. So if we have a horizontal major axis and an ellipse, it kind of looks like an oval almost. It's going to have that kind of shape to it. And then opposite that, when you have a vertical major axis, that's going to look more like this. Okay? So you've got something to characterize those for yourself. Now, what distinguishes this from an equation is that A and C are going to have the same sign, but they're not going to be the same value. Okay? So when you're done today, you'll be able to characterize whether it's going to be a circle, a parabola, or an ellipse. And then tomorrow we transfer over into the hyperbola. So keep this sheet out because you're going to refer back to this. And I'm going to hop over to my note sheet. Let me make sure I am sharing this. All right. I'm going to start right here on my ellipse notes. And I'm going to have you write down a lot of details today. If you have different colors, and just keep everything nice and organized. So an ellipse, here's what you need to know. It uses H and K just like your circle. So H and K represents the coordinates of your center. So that is going to be your center. And I have a lot of little details I want to make sure that you add and kind of keep all in one place. Next over here, whenever we have our major axis, there's a little formula, teeny formula. So our major axis is always going to be 2 times our value of A. And then our minor axis is going to be 2 times the value of B. So you're going to have an A, B, and C today. So minor axis is equal to 2 times B. Next thing I want you to kind of write down here is if you look at this picture, you will see that so your A goes right over here, and this is going to be called a vertice. Same thing up here, same thing up here, and down here. So an ellipse has 4 vertices, and to find the vertices, what you're going to do, so I'll make a little category here. So vertices, the rule is you're going to do plus and minus A to the major. So whatever value is your major, your X or your Y. And then you're going to do plus and minus B to your minor. And again, we'll do big examples of this as well. Next item you're going to see on here, if you look really close, are 2 values that are labeled with F. And those are referred to as your foci or foci, however you kind of want to pronounce that. And what you're going to be doing for this is you're going to go plus and minus C to whichever is your major. So to your major. And before we jump in and kind of do one of these all out, your 2 equations are present right in your box as well. The first equation is when our major axis is parallel to the X. So this is the one that is the horizontal major. And that's the equation you use for that one. So this is a horizontal major. And then my other equation is my vertical major. So this one is my vertical major. And again, if you are a picture person, the horizontal major looks kind of like this. The vertical major kind of looks more like that. Right. Next, before we jump in and start one, you'll see that you have below Pythagorean theorem listed for you. So your A is your distance from here to here. B is your distance from here to here, which is your minor axis. And in the instance you have to find C, you're just going to use a version of your Pythagorean theorem. Okay? So keep this nice and organized today because these questions involve a lot of detail. So number 1, our task is to find the center, the foci, and the vertices for this equation in general form. Now, I want you to get comfortable identifying what these are. So if you look at your formula sheet, I want to figure out if this is a circle, ellipse, or parabola at this point. So you're going to look at the A and the C values. Are they equal? No, one's 4 and one's 9. So this is going to be an ellipse. So I want you to just, again, it's good practice. This is an ellipse. And the reasoning is because it has an A and a C, and they are different in the same sign. So A and C are not equal and have the same sign. So these have the same sign. They're both positive. Okay, so we're going to scaffold this process and get everything all situated. Now, when you do these today, you're going to be pulling back that completing the square knowledge that you used before break. So the first thing I have to do with this is I have to go and complete the square. So I have to rearrange this. So I'm going to say rearrange here first. So rearrange. So I'm going to put x next to x. So I would go 4x squared. What comes next? Minus 8x. And then plus 9y squared. And then minus 54y. And then the constant, if you remember, goes to the other side. Minus 49. The next thing I'm going to do is I am going to take my numeric GCF out of those terms. So I need to take out just the 4. And then this gives me x squared minus 2x. And then I'm going to take out the 9. And I'm left with y squared minus 6y. And then this is equal to negative 49. And now what I'm going to do is completing the square. So CTS, just because it gets kind of long to write. So what I do is I look at my negative 2 and I take half of this. So I go half of negative 2, which is equal to negative 1. Negative 1 squared is equal to 1. And this is the part you want to be kind of careful with. So I'm going to add it right here. But now I have to think about what that makes the other side. So right now, that's not really like saying 1. It's really like saying 4, because you would distribute the 4. So when I go over to this other side, I do negative 49 plus 4. Okay, so just be careful. Now I do it again. So now I'm going to look at my negative 6. So I'm going to go half of negative 6, which is equal to negative 3. And then I square that. I get 9. And I add that value to both sides. So this is 9. And then y squared minus 6y plus 9, which means the other side gets an 81 onto it. Now I'm going to take those and factor them. So I have a 4, and then I'm going to go x minus 1 squared plus 9, and then I'm going to go y minus 3 squared is equal to negative 49 plus 4 plus 81 is 36. If you pick up your formula sheet right now, you will notice that the ellipse is equal to 1. So that means I have to divide everything by 36. So I divide by 36, divide by 36, divide by 36. So I get x minus 1 squared over 9 plus y minus 3 squared over 4 is equal to 1. And there's your equation for your ellipse. Now, what you need to do is determine your major axis. So you look at the bottom and you say the bigger number, is it under the x or under the y? So my bigger number is under the x. So that means my major axis is my x-axis. So this is a squared because it's bigger. So this is my major axis. So the major is going to be the x-axis. So if a squared is equal to 9, it means that a is going to be equal to plus and minus 3. Now I go underneath the 4, and underneath the 4, that means that that is my b squared value. So that means for b, I'm going to use plus and minus 2. Now I'm going to keep going and write all my information out. So I need to identify the center, which you guys are comfortable with. You've done that before in the past. So center is going to be opposite signs, just like the circle. So 1, 3. And now what I'm going to find are my vertices. And again, nice detailed notes through this. So to find the vertices, what I'm going to do here is I am going to do x, because it's my major, plus and minus a. So a always gets added to the major. So I am going to do here my center. So I'm going to do 1 and then plus and minus this 3, and my y value stays the same. So my vertices would be 1 plus 3, which is 4. And my other vertice for the x, 1 minus 3 would be -2, and then 3. Now I'm going to do the minor. So now I'm going to take the y value and do plus and minus b. So y plus and minus b. So my y value is 3. So that means the x stays the same. So I'm going to go 3 plus and minus 2. And I always do the major first. So we're going to have 1, 5. And the second one is at 1, 1. And again, these are your 4 vertices. And I am going to have you do a picture for this one, just so that you have a visual of what this looks like. So they're all 4 vertices. So what remains before I create the graph is to calculate my foci. So to do that part, I am going to use a formula. I need the C value to do this. So you're going to use a version of Pythagorean theorem. So on the front, well, above on your notes, we're going to use C squared is equal to A squared minus B squared. So C squared is equal to A squared, I'm looking for it, was right here, 9. And then B squared was right here, 4. And a lot of these are just going to be radicals. So C squared equals 5. Therefore, C is equal to plus and minus the square root of 5. And what you're going to do is you're going to add and subtract that to the major. So the major was the x. So that's what we add this on to. So I'm going to say add and subtract to major, which again, in this case for us was x. Okay. So I'm going to take this center point again, and I'm going to go 1 plus and minus the square root of 5, comma 3, which means that my 2 foci are located at 1 plus the square root of 5, comma 3, and 1 minus the square root of 5, comma 3. So here are your foci. All right, so here's a picture, just a sketch of what this looks like. So our center was located at 1, 3. Just a little picture. And this is it on this one. So for spacing, you don't need any more room. So here's my center. And then what I do is I'm going to go over the 3. And then this way too. So I have -2, 3 is my other vertice. And then 1, 5, 1, 1. So it kind of looks like this. Okay. And then if you wanted to label your foci, you could. You would just put these values in the calculator, but they're just going to be located somewhere in the interior. So, you know, somewhere like that. Okay. All right, how is the first ellipse? Again, very heavy on the details for sure, but this is what we call a horizontal major axis. So if you flip, now I'm going to give you a vertical major axis instead. So I'm going to walk you through the procedure, how you do that one, and then you want to look for all these distinguishing features. First and foremost, let's classify this again. Is it an ellipse, a circle, or a parabola? Because just pretend I didn't tell you. So in this case, again, my A value and my C value have the same sign, 18 and 12. So this is another example of an ellipse. And again, a great reason to write is you have the same sign on your A and your C. So same sign for A and C, and they're not equal. And again, tomorrow we tack on the hyperbola. So the first thing I need to do once again is rearrange this so I can utilize my completing the square process. So I'm going to rearrange. So I have 18x squared followed by a minus 144x plus 12y squared minus 48y is equal to negative 120. I'm going to again take out my GCF here, just my value. So 18, and then I have x squared minus 8x plus 12. And then this would be y squared minus 4y. And this is equal to negative 120. So now you're going to complete the square twice again. So I'm going to underline my -8, take half of it square, add it to both sides. So half of -8 is -4. And -4 squared is 16. And I'm going to add this value to both sides, keeping in mind that I do have to multiply it by that 18 to keep it balanced. Over here, this would be negative 120. Is that 288? What is 18 times 16? Yes. So plus 288 goes over here. 288. All right, now I do it again. So I'm going to look at the -4. So I'm going to go half of -4, which is equal to -2. And -2 squared is equal to 4. And again, both sides. So I'm going to have plus 12, and then a y squared minus 4y plus 4 hop over to the other side, plus 48. Okay, so keep going. Yes, these are long problems. So I have 18 and x minus 4 squared plus 12 and y minus 2 squared is equal to 216 is what that works out to be. And again, because this is an ellipse, it needs to be equal to 1, signifying that I need to divide all of my terms by 216. So divide by 216, divide by 216, divide by 216. And now what I do is just reduce these. So 18 divided by 216, math, enter, enter. This just gives me 12. Plus y minus 2 squared over in 12 divided by the 216 leaves me with 18 on the bottom equal to 1. So a squared is always located beneath your major axis. So this time my larger number is underneath the y, indicating that I have a vertical major axis instead. So again, all those are good details to kind of immediately write down. So this is my a squared, which means a is equal to plus and minus the square root of 18. And again, this indicates that I have a vertical major axis instead. So here's my b squared value, indicating that for b, we're going to go plus and minus the square root of 12. And now I just have to kind of write my defining characteristics. So I have a center located. So I'm going to say center. And my center is at 4, 2. And now I need to continue onwards and find all of these vertices. Again, nice detailed notes. So for my vertices, I'm going to start with my major axis again. So for my vertices, I'm going to go y plus or minus a. Because again, y is the major. So it's different than the other problem we just did. All right, so my center, so I have 4, and then comma, I'm going to go 2 plus or minus the square root of 18. So this is going to be 4, and then 2 plus the square root of 18. And then 4, and then 2 minus the square root of 18. If you want to break it off like that. If you want to leave it all together, totally fine. Now I'm going to do my minor. So I'm going to do x plus or minus b. So my x value was 4. So I'm going to go 4 plus or minus the square root of 12. And then the 2 stays the same. So these are going to be 4 plus the square root of 12. Comma 2, and 4 minus the square root of 12, comma 2. How's that, okay? Okay, I tried to keep it nice, detailed, and consistent for you. The last thing that remains are the foci. All right, so let's do that up now too. Foci means I need the c value. So I need to do c squared equals a squared minus b squared. All right, so I have 18 minus 12. And again, all these are pretty much going to be radicals, and it's okay. So c squared is equal to 6. So c is equal to plus and minus 6. And this time you are going to add and subtract this value to the y instead. Since that is your major axis, but I know I'm making you do a lot of writing today, so kind of abbreviate that a bit. So last but not least here, because this one I'm not going to have you graph. So I am going to take my center and I'm going to go 4, so that stays the same. And then I'm going to do 2 plus and minus the square root of 6, which can get broken off into foci 1 would be 2 plus square root of 6. And then my second one would be 4, and then 2 minus the square root of 6. All right, and these are your last two answers. So these are all your vertices, and those are your foci. All right, how do we feel in those two? Okay, you got good organized notes, I hope. Perfect. Again, use a lot of paper to do these. Keep things organized so that you can kind of, keep your train of thought together. All right, this one's much quicker. Now, I've given you some characteristics. You're going to write the equation. Write the equation of the ellipse. So you know it's going to be one of the two from your sheet. Center is located at -5, 3. So again, this refers to H and K. I am going to draw a sketch of this because that helps. -5, 3. I'm going to go 1, 2, 3, 4, 5, and then 1, 2, 3. So that's here. I have a vertical major axis. That tells me that's this formula. X minus H squared over B squared. Remember, A squared is always over the major. And then plus Y minus K squared over A squared equal to 1. I have a major axis with a length of 8. So I'm going to do 2A, because A gets used per major, is equal to 8. So therefore, A is equal to 4, but the formula requires A squared. So A squared is equal to 16. So that will fill in a second. You're almost there. Horizontal minor of 2. So the 2 is my B value. So 2B is equal to the 2. So B is equal to 1. And then B squared, coincidentally, would also be a 1. All right, so here's my answer. I just take all those values, slide them in. So I am going to go X minus H. So I'm going to go X plus 5 squared divided by B squared, which was 1, plus, and then I'm going to go Y minus 3 squared over 16 is equal to 1. All right, so this is your solution. But again, the pictures I think are very helpful sometimes. All right, how's that one, guys? Decent? Okay. And again, if you wanted to plot this, vertical major axis of length 8, so half of that, so that means I go up 4, down 4, and then over 1, over 1. So it looks like this, if that helps. Okay, so that's what a vertical major axis kind of looks like. All right, so change gears, and on the practice sheet, we're going to do just some of these. So I want you to look at number 3, number 4, and then the 4 at the bottom are really, really super quick. All right. So I want to look at this sheet. And number 1 and 2, we already kind of did all those parts too. Again, if you want to go back and do those tonight, you're more than welcome to. I posted those answers for you. But I want to concentrate on 3 and 4 first. So number 3. So this is going to be the equation of an ellipse, and it has to satisfy these conditions. So your foci are located at -2, 1 and -2, 7. The first thing you want to look at is which one of these values changed. And obviously the y's are different. So that means that you did something to the y. And when you do something to the y, this indicates that we have a vertical major axis. So this is our vertical major, because the y's have changed and had something added to them. A is equal to 5, that's given to you. I'm going to start and build this equation. Vertical major means I have x minus h squared over b squared plus y minus k squared over a squared equals 1. I'm going to start putting some things in here. So I'm going to sketch this. So I have the points -2, 1 and -2, -7. So -2 and then 1 and then -7. So I'm like down here. What you're going to do is go exactly halfway in the middle and place your center. So here's my center. So I'm going to state that my center is located at -2, -3. I'm going to go put that in now. So I have x plus 2 squared over something, and then plus y plus 3 squared. Actually, we already have a. So therefore, a squared is just going to be equal to 25 equal to 1. All right, we got one more thing to find. I need the b value. Find the b value, I'm going to utilize the c value. The c value is the distance from my center to my focus right here. So this is c. And in this case, that is just represented by 4 units. So I'm going to do c squared is equal to a squared minus b squared. So 16 is equal to 25 minus what? So what would b squared have to be? Just 9. Answer. Your equation is just that. Okay. All right, number 4 is very similar. The length of the major axis is 6. So that is indicating that A is equal to 6 because it's my major. My foci are located at 0, 2, and 8, 2. So this time, my x has changed. So this one is going to utilize a horizontal major axis. So this one is horizontal major. So that's what you're kind of looking at. You can use this space. So our formula is going to be x minus h squared over a squared instead. Plus y minus k squared over b squared is equal to 1. All right, I'm getting there, pretty close. I'm going to plot this and kind of see where we're at. So another graph. And I'm going to plot 0, 2, and 8, 2. I'm immediately going to go right in the middle, halfway, and that is going to be my center, right here. So I have a center located at 4, 2. We'll slide those in a minute. And then now I'm going to count my C value, which coincidentally is the same as the other one. It's just 4 again. So C equals 4. Or you can use the other side. It makes no difference whatsoever. All right, so what do I have so far? I'm going to have x minus 4 squared over, if a is 6, then a squared is 36. Plus y minus 2 squared over something. We're going to find that equals 1. All right, so I need to find the b value once again. So I'm going to find some space and I'm going to do that formula one more time and you are good from there. So I'm going to say that c squared is equal to a squared minus b squared. So c squared was 16. A squared is 36. And I'm just asking myself, basically, 36 minus what number gives me 16? So b squared is just 20. And that's it. So the 20 goes right there and you are done. So over 20. Okay, how are those two? Okay, again, very detail oriented. Hop down, please, to these last 4. So to conclude, let's make sure that you can characterize the difference between a circle, parabola, or an ellipse. So what makes a circle unique from its equation is that my a value is equal to my c value. So on here, which would be my circles? Number 9, because a and c are both 4. So here's a, here's c. So this would be a circle. Why? Because a and c are equal. Is there another circle? Yep, go over to number 8. That's a circle as well. So here's a, here's c. So this is another circle. Same reasoning applies. A equals c. To have a parabola, this is only going to have x squared or y squared, not both. So this is x squared or y squared. Are there any of those? Yes, right here. So this one is a parabola. Your reasoning, you can say it only has x squared, which indicates that c is missing, so it's 0. And then last is your ellipse. And an ellipse, a is not equal to c. And numerically, they have the same sign. So this is your ellipse. A not equal to C, and they are both positive. Okay, so I'm going to stop there for today because that was a lot. Tomorrow, we're going to pick up with the hyperbola. Again, your assignments for this week are 2 textbook assignments, and there is a worksheet that was stapled in that packet that says conics review. Which if you wanted to start tonight, you would be able to just identify which ones are parabolas, circles, and ellipses, and those you'd be able to do. Next Wednesday, when you return to, we will be doing review of just this unit, and then we move on to sequences and series thereafter.